In this video, I'm going to talk about right-angle trigonometry. First, though, I'm going to review some basic terms that we should be familiar with in order to follow this video. Okay, so an angle is called an acute angle if it's between 0 and 90 degrees. If the angle is exactly 90 degrees, we call it a right angle. And if the angle is greater than 90 degrees, we say it's an obtuse angle. And if the angle is exactly 180 degrees, we say it is a straight angle, such as a straight line. Now, we also know that the sum of the angles of a triangle are 180 degrees, and we say that two angles are complementary if their sum is 90 degrees. Similarly, we say that two angles are supplementary if their sum is 180 degrees. Now, here we have a 90-degree triangle, or a right-angle triangle, and by this I just mean it's a triangle where one of the angles is 90 degrees. Here I'm going to label each of the angles with a uppercase letter, so A, B, and C, and then each of the sides I will label with a lowercase letter, such that the side opposite an angle has the same letter. So you see we have angle A is opposite side little a. Now note that we indicate that an angle is a 90-degree angle or a right angle, such as angle C here, by drawing those two perpendicular lines over that angle. Okay, so given a right angle triangle, we know that a squared plus b squared equals c squared. So this is called the Pythagorean theorem. Now sometimes we might refer to angles by Greek letters instead of uppercase letters. So here I'm going to refer to angle B as theta. Now note that for any right triangle, the side opposite the right angle, so in this case the right angle C, so little c, is called the hypotenuse. Now the other two sides we give different names to depending on what angle we are referring to. So letting angle B be theta, we then are going to call the side next to or adjacent to angle theta the adjacent side, and the side across from it or opposite to it we will call the opposite side. Now, getting into the definitions of sine, cosine, and tangent, we're going to define sine of theta to be the opposite over the hypotenuse. So in this case, sine of theta is b over c. Cosine of theta we will define to be adjacent over hypotenuse, which is a over c, and tangent will be opposite over adjacent, so that is b over a. Now note that we sometimes refer to this as the SOHCAHTOA definition. So if you look at each of these three different words, so, ka, and toa, the first letter refers to which trig function we're talking about. So the so starts with an s for sine, the ka with a c for cosine, and the toa with a t for tangent. So if you can remember SOHCAHTOA, that can help you remember whether it's sine or cosine that is opposite over hypotenuse. So if you're looking at it, we have SOH, so that stands for sine, opposite, and hypotenuse. Ka, which is CAH, is cosine adjacent hypotenuse, and the TOA, TOA, is tangent opposite adjacent. So that's a little trick for remembering the definitions of sine, cosine, and tangent. Now, just some quick observations. If we look at sine divided by cosine, well, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now, just remember that dividing by fractions is the same as multiplying by the reciprocal. So this is the same as opposite over hypotenuse times hypotenuse over adjacent. And now the two hypotenuses will cancel, and we're left with opposite over adjacent, which is just tangent. So therefore, we know that tangent is the same as sine over cosine. Now, a second observation, if we're given this right angle triangle here, first off, we know that the angles of a triangle are 180 degrees. So that tells us that since angle C is 90 degrees, the sum of angles A and B are also 90 degrees. In other words, A and B are complementary angles. Now, if we look at sine A, remember sine is opposite over hypotenuse, so the opposite of angle A is little a, and the hypotenuse is C. Cosine is adjacent over hypotenuse, which is b over c. Now for sine b, the side opposite sine b is little b, so we have sine is b over c, and cosine is a over c. Now you'll note here that sine a, which is a over c, is equal to cosine b, and that cosine of a is equal to sine b. So from this we have a theorem that if two angles are complementary acute angles in a right angle triangle, then we know that sine of one is equal to cosine of the other.